Now that we understand the inclination of a graph, let me explain what happens with parallel lines and perpendicular lines. So the one we are going to look at first is parallel lines. So here we have our Cartesian plane again, with two lines drawn. Okay, so the information given is that these two lines are parallel. Okay, now I say let this angle be theta. Now if we know it's parallel lines, we know that we can apply vertically, we can apply that fun rule, right? Corresponding angles, co-interior angles, and vertically opposite, not vertically opposite, alternating angles. So let's look at this one. If this is theta, right over there, then the angle here at the bottom is also theta, alternating angles. If this is theta, we know that the vertically opposite angle is also theta. So you can see that we have two angles. The inclination angles of these two lines are both equal to theta. They are equal to each other. So this is line 1, that is line 2. So if for line number 1, m1 is equal to tan theta, but for line number 2, m2 is also equal to tan theta. If that is the case, therefore m1 equals m2. Now this is just to help you with understanding it. You never have to prove it like this. You don't need to know how to prove it, but it helps you to understand why they are equal. So in a test, an exam, anywhere, you just need to know that parallel lines have the same gradient and their inclination angles are exactly the same. Okay, now we're going to look at perpendicular lines. Okay, so a perpendicular line will look like this. Let's just redraw our Cartesian plane, and you have a line going like this, and then one that is perpendicular to that line. Okay, so let's say we've got a theta there. This is line number 1, its angle of inclination or inclination, and this is line number 2, and alpha is its angle of inclination. Okay. I'm not going to go into detail of explaining why the following rule applies, but for grade 11 you need to know how to apply it. Okay. So m1 times m2 will be equal to -1 if the lines are perpendicular. So in a test, you just need to know this. You just need to be able to apply it. Okay, so for instance, let's rather call this line, let's say A, B, C. Let's just call those coordinates A, B, C. And it's given, they give you in the question that AB is perpendicular to BC, and you have the gradient of AB, line number 1, and you need to calculate gradient of line number 2, BC. Then you literally start with the following. You write down, you say M1 times M2, or in our case, this will be AB, BC. And then your reason, you have to give a reason always, right? In the reason, you just say AB perpendicular to BC. And then from there, you calculate. So let's assume, for instance, we know that MAB was 3/2. you will see that our final answer for BC will be negative 2 over 3. So the quick way to calculate this, you look at the fraction, you swap the numerator to the denominator around, in other words, you take the reciprocal of it, and you put a negative in front. That's the quick way to calculate it. But let me show you mathematically how it will take place. And so in a test, you need to show this if you want to apply this. But you don't need to show the rest of the calculations. You can immediately write down the answer because it is assumed that you can use that way of thinking. Okay, but now let's say therefore 3 over 2 times MBC equals negative 1. So MBC is equal to negative 1 divided by 3 over 2. And there you can see what's going to happen to the reciprocal. So therefore MBC is negative 2 over 3. And this is how you apply parallel and perpendicular lines in analytical geometry.